All right. Hello, everyone. Welcome to Unlocking Usaco. So, today we are going to be going over the problem subsequences summing to 7. So, this is one of these problems where you think that, okay, there's a pretty obvious solution, but that pretty obvious solution times out. And one of the ways you can optimize solutions, as we will see later, is by using math. Alright, so let's read the problem statement. Farmer John's N cows are standing in a row, as they have the tendency to do from time to time. Each cow is labeled with a distinct integer ID number, so FJ can tell them apart. Farmer John would like to take a photo of a contiguous group of cows, but due to a traumatic childhood experience involving the numbers 1 through 6, he only wants to take a picture of a group of cows if their IDs add up to a multiple of 7. Please help FJ determine the size of the largest group he can photograph. Alright, so basically, this is the key word. He wants to take a contiguous group of cows, and their sum needs to be a multiple of 7. So let's go over to our sketchpad. Here we have our test case. And the key words, like I just said, are largest consecutive group with sum. That should automatically set the alarm bells off that this is a prefix sum problem. So that being said, let's take the prefix sum. So we go from here to here, and basically, again, how a prefix sum works is you are just taking the sum of all the numbers before it. So if I was to go take the prefix up until this 5 right here, I'd just be doing 3 plus 5 because I'm summing the number at that indice and all indices before it. So pretty straightforward. So yeah, that leads to this prefix sum right here. Alright, so we still need to find all the subarrays and take the max subarray that has a sum divisible by 7. But if we do all of those subarrays, then it's going to be O of n squared. So how do we optimize this? Well, the key thing is, because we need the largest group divisible by 7, we only care about the remainders of each number. So why do we only care about the remainders? Well, if we only want to know if it's divisible by 7, then we don't really care what the original numbers were. Because if you have, say, an array of 1, 0, 2, and 3, this sum is equal to 6. That's not divisible by 7. Now, say we have instead an array of 8, 7, 9, and 10. That sum is equal to 34. But that's also not divisible by 7. And what's more, the remainder, if we take this modulo 7, is going to be 6. So see how it boils down to our remainder? So using that, we can just take all of the numbers in our prefix sum modulo 7. But how does this really help us? Don't we still need to compute all the subarrays? No. By the prefix sum formula, we have that the prefix sum of a segment LR is equal to the prefix sum at index R minus the prefix sum of index L minus 1. So, what does this give us? Well, if the segment is divisible by 7, then the remainder will be 0. So, if we find two indices with the same value, the segment will be divisible by 7 because pref R minus pref L minus 1 will equal to 0 in that case. So therefore, the problem boils down to find two indices with the same value that are the farthest away from each other. And doing that on our test case gets us an answer of 5, which is exactly our sample output. now that we know the algorithm and we have a better understanding of how to approach this problem, let's look at the code. So here we have my code for subsequences summing to sevens. So I use a custom fast IO class for my input output. So this is the Kattio class. Pretty straightforward. You can look at the specifics of the class implementation on the usaco.guide. I'll link it below. And until then, we're just going to go over the rest of the code. So I read in the number of cows we have, and then I create two arrays, the prefix array and the regular array. So I made these both one indexed, which is the standard for prefix sums because of how you compute them later, but there can be some bugs that arise with these, so I'm going to point those out later. So I populate the array, and then I'll touch on why I do these later. So basically I make my prefix sum, and then this is how I'm going to get my indices that have the same value. So I create a hash map that has indexes of long and that has keys of long and values of arrayless integer. And then the idea here is this is going to be the number, the remainder, and then these are going to be all the indices that this remainder pops up. So by doing just a forward traversal, we'll get whether that remainder is already in the map, and if so, we're just going to add the indice. Otherwise, we're just going to put the key value pair of that indice and that remainder. So, okay, that's just debugging. All right, and now we need to iterate through all the values in this map and figure out which one is the maximum difference. So the reason why I'm not sorting this here is because since we preserved order when traversing, the last value is going to be the latest indice that remainder appears, and the first indice is going to be the first time that indice appears. So I can just subtract the first value in that array list from the last value in that array list, and then update the max variable. And then we just print out max, and we're good to go. Now, okay, let me touch on why I did this. So one of my bugs was that I see how I'm iterating here. So basically, when I was iterating, it was counting my first index, which is not assigned to any value, as a valid residue. So if I had like, I don't know, 0, 1, 3, 4, 3, 5, 3, 0, it was thinking that this unassigned 0 was actually a value, and then it was throwing off my calculations. So the fix was I had to reassign that first indice. So that threw me off a bit. It was an error I spent unbelievably long debugging. But yeah, so watch out for that. Watch out from where you start traversing and what your indexes are, I guess. So that being said, let's run this. All right, so we are on the problem statement. I'm going to attach my file, and we are waiting. Quick note, this is one of these files that needed file IO, so make sure you change that before you submit. And look at that, we got perfect score. So yeah, that's my walkthrough subsequences summing to sevens. Key takeaway is try to use math to simplify problems that can either contribute to optimization or just make the implementation of the problem a lot easier. So that's all for today. Bye.